Dear students, now we will continue on building the UPGMA phylogenetic tree. So just to revise a few things, the UPGMA is a clustering approach towards creating phylogenetic trees, and the phylogenetic trees are very useful in helping us understand the evolution of sequences. In the phylogenetic tree construction, there are two components. The first is the connection between sequences and cluster. So if you have two sequences, you can create a cluster, or if you have a cluster and a sequence, you can create another cluster, a new cluster. The second condition is, so you have two trees or two subtrees which you want to join. So the UPGMA treats both of these conditions and gives you a complete tree. The formula to compute the distance between a sequence and another sequence, or a sequence and a cluster, is given here, as you would know by now, and the distance between two trees can be computed using this formula. So let's continue with our example. If you remember, we had created a cluster W out of V and E. So we were in need to calculate the distance between W and B, W and C, W and F, and as a result, V and E will be eliminated from the distance matrix. So let's see how we calculate the distance. So the distance between W and B is very easy to calculate using the formula. So the number of sequences in V, so remember, V was a cluster with sequences A and D, so it has two sequences. So here you input 2. Distance between V and B, so V and B have a distance of 6, so here you go. And the number of sequences in E, so E is still one sequence, and the distance between E and B here, so it is 6, and you divide it by the sum of 2 and 1, so the answer is 6. So hence the distance between W and B is 6. So similarly, you compute the distance between W and C. So number of sequences in V are 2, because you have A and D here, so you have 2. Distance between V and C is 8, so it comes here. The sequences in E are only 1, and the distance between E and C is 8. Of course, you divide it by the sum of the number of sequences in E, so that is 3 in all, 2 plus 1, and the distance between W and C comes out to be 8. Similarly, you can compute the distance between W and F. So if you look carefully now, you have computed all three distances and you are ready to update your distance matrix. So let's see how it goes. So this was your distance matrix with V and E. Now V and E have been replaced by W here. So here is W, and the distances 6, 8 and 6 were just computed in the previous slide, and therefore you have the updated distance matrix. So you would have noticed that our distance matrix is shrinking while we are clustering different sequences and clusters. Now, if you remember, A and D were grouped into cluster V, and V and E were grouped into cluster W. Now if you look at the distance matrix, the shortest distance that is stated here is 4. And this is between B and F. Now B and F are both sequences and not clusters. So clusters are V and W, while the sequences that are still with us include B, C and F. So now the distance between B and F is 4, the shortest distance that is there in this entire matrix. So we create a cluster between B and F, and the distance is obviously 2. So 2 here, 2 here. So if you add it, then this is equal to 4, which is written here. So let's name this cluster as X. So now you have 3 clusters, V, W, and X, and only C remains in the distance matrix. So 3 clusters and 1 sequence remain. So now the things to remember are that 2 trees have been formed, 2 separate trees. And now we would want to join them together using the second component in the UPGMA algorithm.